Hello everyone. Myself, Vikash Kumar Singh from BTech, final year, Civil Engineering Department, University of Lucknow, Faculty of Engineering and Technology. Today, I am here to present my seminar on the topic anti-collision device. Moving to the next slide, here we have table of contents, introduction, why we need ACD, components of an ACD, working of an ACD, ACD network, salient features of an ACD, advantage of ACD, disadvantage of ACD, application of ACD, case study, future scope, and conclusion. Moving to the next slide, here we have introduction. Anti-collision device in rails are meant to avoid collision of two or more than two trains. The anti-collision device network in trains was invented by Raja Ram Boji and patented by Konkan Railway Corporation Limited. ACD is relay on GPS satellites for position updates. They exchange information through radio frequency transmission to automatically to the brakes and prevent collision. When ACD are installed in locomotives along with an auto braking unit, ABU, station and level crossing gate, the network of ACD system prevents high-speed collisions in mid-sections, station area, and level crossing gates, thereby saving the lives of rail passengers and other users. Moving to the next slide, here we have why we need anti-collision device. In August 1995, Firozabad train collision, 358 people died. On August 1999, head-on collision at Gasal, 300 people died. At December 2000, Sarai Banjara rail disaster, 46 people died. In January 2003, Ganganadur train crash, 18 people died. On June 2004, Karanjadi train crash, 20 people died. On June 2023, Odisha train crash, 26 people died with 200 other people injured. Moving to the next slide, we consist of components of ACD. Mainly, anti-collision device is divided into two parts. First, fixed ACD, which consists of station ACD, level crossing ACD, loco set ACD, etc. Secondly, mobile ACD, which consists of loco ACD and guard ACD, etc. Moving to the next slide, here we have working of ACD. In the ACD, the radio signal from the constellation of global positioning system (GPS) satellite or received by GPS receiver through the antenna. This signal sent to the command and control unit, that is CCU, to extract the parameters related to the movement of locomotive like latitude, longitude, speed, angle, date and time. Moving to the next slide, we consist of ACD network, manufacturing and installation of ACDs with accessories, making individual commission for ACD installation, training of personnels, post-warranty, annual maintenance. Moving to the next slide, we consist of salient features of ACD, detection and prevention of head-on, rear-end, and side collisions. A unique feature even when a train is not protected by a signal as in a block section. Train approach warning for road users at level crossing, both manned and unmanned. In addition, at manned interlocking level crossing, reducing the train speed to 30 km per hour. Moving to the next slide, we consist of advantage of ACD. Collision prevention, enhanced safety, improved operational efficiency, reduction in human error impact, dynamic speed control, cost saving through accident prevention. Moving to the next slide, we consist of disadvantage of ACD. Initial implementation of cost is high, maintenance costs are high, complexity and technical challenges, training requirements, false alarms, dependence on power supply, cyber security concerns. Moving to the next slide, we consist of applications of ACD. ACDs can be implemented in railways to prevent collisions and to increase the tolerance between two consecutive trains running one after another. Development of high-speed trains with high safety measures. It can be used in heavy vehicles like cranes, earth movers, etc. to prevent accidents and for their safe working in public places. With few developments, it can also be used in automobiles for prevention of road accidents. ACD can be used as a tracking device. Moving to the next slide, we consist of Pilot project of Konkan Railway. Total distance covered was 1736 km with 48 locomotives. Route of placing was from Katihar to Malda. Railway zone was Northeast Frontier Railway. Project has been in service trials since 2006. Total installation cost of ACD was 10 to 12 lakh per route kilometer. Moving to the next slide, we have pilot project of South Central Railway. Total distance covered was 50 kilometers. Route of ACD placing was Lingamapalli to Bidar. Railway zone was South Central Railway. Project has been in service trials since 2010. Total project cost was 10 to 12 lakhs per route kilometer. The project cost is estimated at about Rs 7,000 crores for Indian Railway. It will cover 64,000 kilometer route, all 6,000 odd stations, and 10,000 odd locomotive engines. The project will be completed in the year 2028. Moving to the next slide, we consist of future scope. The idea of incorporating radar system into vehicles to improve road safety. Such systems are now reaching market as recent advances in technology have allowed the signal processing requirement and the high angular resolution requirement from physically small antennas to be realized. Automotive radar systems have the potential for a number of different applications in anti-collision devices. The problem of this device is to decrease the cost of the device. Moving to the next slide, here we have conclusion. Indian Railway is the world's second largest railway with 6,853 stations, 63,028 kilometers of track with 37,840 passenger coaches. Annually, it carries 4.38 billion passengers, and all human being safety is a major duty of Government of India. At level crossing, two ACDs network provides the train approach warning to road users and regulates the train speed automatically. This ACD system provides a bigger help in protection and control in train accidents and recently named as Kavach. Thank you.